Hello, everyone. Welcome back to the second season of Tux. Let's thank all of you for coming, and for us as a group, welcome back. So Tux now has continued to expand. We have several member organizations spanning universities from as far west as Waterloo and as far east as Queens, and several corporate members as well. And of course, there are many people in this audience who are from here at the Mars community who haven't formally joined up, and really all that means is sending us an email and saying, hey, I'm here and I want to have my logo as part of the Tux organization, and that's sort of all there is to it. But the goal of Tux, of course, is to bring together all of the exciting talent, both in the research, the sort of ivory tower academic communities, to the people who actually have real jobs building things in HCI, and bring everyone together in an exciting and vibrant community. And I've been very privileged to hear all the great conversations that have been going on. So for those of you who don't know us, my name is Daniel Wigdor. I'm an associate professor of computer science at U of T.
I'm Ali Mazalik. I'm a Canada Research Chair in Digital Media and Innovation and associate professor at Ryerson University.
And I'm Toby Grossman, a research scientist at Autodesk Research.
Excuse me, that's not the right title, right? Come on.
Sorry. Distinguished research scientist.
There we go. So the three of us comprise 3/4 of what we have termed the editorial board, which is essentially the group who issue the invitations to our external speakers and looking at all of the internal speakers to make an exciting program over the course of the year. There also are several other people here in the audience who have made great contributions to the organization. Daniel Vogel, who's a professor at Waterloo, is our web chair. Kai Trong, who is also on the editorial board, organizes all of our recordings. Most important of all is our food and beverage chair, which is Sue-Ann Dam, who has been outside coordinating all of the great food. And of course, we have excellent coordinators as well, working with Sue-Ann to make it all go smoothly. So on to Toby.
Great. So for those of you who were around last year, as Daniel was saying, this is our second year. We run these lectures typically every 2 weeks. Sometimes there's little blips in that, so we'll have the schedule posted on the website, which I'll mention in a moment. But we alternate between the Sanders Series lecture and the Tux members' talks. So the Tux members' presentations are for members of our community that present within these 1-hour time slots. And then the Sanders Series are distinguished lectures from academics or industry members that are really leaders in our field coming from international locations. And we're really excited to have Ken here today, kicking off the Sanders Series lecture for 2016-2017. So most of the schedule is now posted up on the website, and we're really excited about the lineup we have. We've finalized the Sanders Series lecture for the winter, and for the fall. For the winter, we'll be posting that very shortly, and the member presentations have been finalized. One thing we're going to be doing differently this year that we're very excited about is Research Poster Day. So in February, we'll invite poster submissions from anyone from our community to come and present. And this will just be another way to get the community to connect and mingle and learn about all the research that's going on within the Toronto area. And you'll also notice on the schedule that we sometimes alternate between this location, the Mars Discovery District, and the University of Toronto location. And as you can see on the map, these are very close together, just a short walk. So hopefully convenient for everyone to get to both.
Okay, and so before we begin, we have some very important people and organizations to thank who are our sponsors, and without whom we would certainly not be able to host these wonderful events and provide food and things. So first and foremost, Stephen Sanders is the sponsor since the beginning of last year of the Sanders Series invited lectures. I'd also like to thank Autodesk, another very important sponsor, the Computer Science Department at the University of Toronto, and then, of course, last but not least, Mars Innovation, which is where we host most of our events. Also, before I introduce Ken, a final little reminder. So we do have our website up online, tux-hci.org, and this is where you can find all the calendar information. You can also add yourself to the mailing list, and then all of the Sanders series lectures are being video recorded, and the talks will be available online. So if you have any friends or colleagues who missed a lecture and would like to see it, they'll be able to watch it later on. Without further ado, then, I'm going to move on to introducing, I'm very pleased to introduce the very first speaker of the Sanders Series Invited Lectures for Year 2, 2016-2017. And it's my great pleasure to introduce a longtime friend and colleague, Professor Ken Perlin. Ken is a professor in the Department of Computer Science at NYU and also the founding director of the Media Research Lab. So he has a long history of highly regarded and impactful research, which broadly spans future reality, graphics, animation, user interfaces, and education. His invention of Perlin noise in 1985 is widely used in computer graphics to realistically simulate things like clouds, grass, wood, stone, water, fire, and much more. And he's also made significant contributions to HCI research, which includes things like zooming interfaces, stylus-based input, and multi-touch input devices. So he's worked in all of these areas. Among Ken's many notable achievements, he's received an Academy Award for Technical Achievement from the Academy of Motion Picture Arts and Sciences for his noise and turbulence procedural texturing techniques, which are broadly used in feature films and television. He also received the 2008 ACM SIGGRAPH Computer Graphics Achievement Award, the Trapcode Award for Achievement in Computer Graphics Research, the New York City Mayor's Award for Excellence in Science and Technology, the Sokol Award for Outstanding Science Faculty at NYU, and a Presidential Young Investigator Award from the National Science Foundation. Ken also served as the general chair of the WIST 2010 conference and formerly directed the NYU Center for Advanced Technology and Games for Learning Institute. And he's also been a featured artist at the Whitney Museum of American Art. Ken received his PhD in computer science from NYU and a BA in theoretical mathematics from Harvard. And before working at NYU, he was head of software development at R. Greenberg Associates in New York. And for all the students in the audience, if you haven't visited Ken's homepage before, I highly recommend that you do, because it's long housed the most wonderful collection of his own little graphics and interaction experiments. I actually came across his website before meeting him in person some 15 years ago and was endlessly fascinated with his little computational gems written in Java that demonstrate and play around with a wide range of mathematics, physics, graphics, animation, and interaction concepts. It's really a wonderful, wonderful little website to visit. So without further ado, please join me in welcoming Ken.
Awesome. Now I want to meet Ken Perlin. All right. Thank you, Ali. So this is a very provocative title because you might be thinking, aren't we already in the age of computer graphics? We're already using computer graphics. I'm going to make this argument over the course of the next 50 minutes that not yet, no, we're not actually there yet, and it's actually very important for us to understand that difference. So people talk a lot about virtual reality these days. It's become a buzzword. Some of you know it's been around for technically about half a century, conceptually far longer than that. But what is virtual reality? I would actually argue that first, in order to understand what virtual reality is, we have to understand what we are. So here's what I think is going on with most humans. Humans kind of live in this world where, you know, there's a mountain, there's a computer, there's a piano, there's France, there's whatever, and you know, we see things, and except that in this landscape of stuff we sort of notice, there are things that stand out, and I think the things that stand out is, oh, there's a human, there's another human. You know, we see each other, and I think what our evolutionary imperative has created for us is that we recognize other human brains, other human minds. And those are very, very unique for us. I mean, when you look at the interest level, what we have to learn from the world around us, I think there are these enormously tall asymptotes that just stand out above everything else. And I think that the entire human project for the last few 100,000 years, depending upon how you count it, has been basically to create these connections between human minds. Everything we do is to create connections between human minds because in fact, we do not see literal reality. We see everything as refracted through this thing we have in common. I mean, if you have an object that on one level you might think is a physical object, you know, a chair. What is a chair? A chair is a concept that we made for human utility that then we put into the world, and you know, or you know, similar objects, a table, or and there are objects that you know that wouldn't even make any sense without human minds because they're physical objects that come out of the you know, human concepts. So there's the idea, you know, of time. So we have clocks. There are physical objects which are clocks, but they only have meaning because of human minds and human communication. And then there are physical objects that are entirely subject to human purposes and come out of human purposes. So for example, what is a fan? A fan is something that humans create in order to accommodate human existence. And in fact, then what happens is we start connecting these tools together. We connected them one way before we had computers and networks, but after computers and networks, we can connect them in even richer ways. So for example, we can conceptually have things like, oh, there's a chair. A chair represents a person being in a room. A person sits on the chair, the fan starts moving. The person leaves the room, the fan stops moving. So we start to have these relationships with the world where we build a physical world that actually represents ideas that only exist in human minds. And because we all have human minds, because we have this in common with each other, we tend to forget that we made it all up. None of it existed without us. And I think the key is that we are all creatures of language. The thing that's our superpower, it is not a technology, it is an instinct that we evolved, is our ability from early childhood to learn natural language. And statistically speaking, except for a vanishingly small subgroup, every human on Earth has the ability to learn human language. And what it essentially is a form of mind reading. I think a thought, and sounds come out of my mouth, travel through the air, you hear them, and those thoughts form in your brain. And we're so used to the fact that everything we do is based on this consensual mind reading that's going on every day that we forget just how astonishing that is, and as far as we know so far, unique in the universe. So I want to talk about what that means for virtual reality. People talk virtual reality, virtual reality. I would say everything is virtual reality. Clothing is virtual reality. We're not wearing clothing in this room right now because of temperature. We actually have fans, so actually the temperature is just fine. We are wearing clothing mostly as a form of communication to each other. And if it's a form of communication that we embody in a technology, it's virtual reality. It's just an older form of virtual reality. And some forms of virtual reality, like clothing, have become so pervasive that we forget that we made them and that they don't exist. To be natural would be to go naked. But in fact, if you try to go naked, people will arrest you, and they'll probably lock you up because they think you're crazy. And if you walk outside without money or without credit cards or without anything, well, technically in many cities, that's illegal. You're allowed to walk around naked without money in your house. That's okay, but you walk into the shared space, there are consensual virtual realities that you are demanded to use. And the reason this is important is everyone's been talking about VR like it's new, because of course, you know, there's going to be the glasses, there's going to be all this stuff, but the principles, the ideas, the purposes to which we put them, and what we drive them to be as communities of humans are not new at all. And that needs to inform how we think about them. So virtual reality shouldn't isolate us, it should connect us. So let's talk about some technological evolution for the next 10 years. And I'm not going to dwell on this too much because I think most of you know a lot of this. I'm just going to talk about, you know, the high level. So right now when we think of VR, we often think of something where the icon of what we think of kind of looks like this. You know, something that looks kind of like, some people call it, you know, variations of it are Google Cardboard, Mark Bolas's FOV2Go from 2012, the stuff Jaron Lanier was doing since 1986, the stuff that Ivan Sutherland was doing in 1968 with Bob Sproul. But in fact, what really happened here is that in 2007, the iPhone and its cousins, the Android, showed up, and we all collectively, within a year, a lot of people realized go back to 1851, Sir David Brewster's variation of Wheatstone's stereoscope, sticking onto this, and whoa, we have graphics, we have an IMU, we have a gyroscope, we have connectivity with everything. So all this is a retrofit of a technology that is 160-something years old. And we have to accept that these concepts have been floating around. When people looked through the stereoscope at the Great London Exhibition of 1851, they were having exactly the same ideas we're having now. But this is because this is found materials. Apple came out with the smartphone and people started retrofitting it. But we know that we're not going to spend most of our lives going like this. This is not the future of shared, we like eye contact. We like being able to see the world around us. We like things that are not heavy floating in front of our face. So in fact, there are a lot of big companies that are working on variations of what I tend to think of as basically hologlasses, however you call them. And hologlasses are just these lightweight glasses. They're going to have some sort of display device. They're going to, and there's going to be some way to get the information from a tiny little, probably 4K by 4K microdisplay for each eye. And when you look at things like the HoloLens, the forthcoming Magic Leap, these are all variants of early forms of what's going to be something that's very pervasive, that everyone will take for granted. And to be clear, when you look at a smartphone, you're looking at a form factor that isn't that different from half a century ago what Captain Kirk pulled out and started talking to Scotty with. And so, the communicator from 1966, Star Trek, it was supposedly something from the 23rd century. And millions of people saw that. And they saw William Shatner looking really cool in his tight-fitting uniform, talking on this thing. But probably nobody was thinking, right, and then in another 50 years, somebody's going to stand on a street corner and use this to call an Uber, and you're going to see a little cartoon representation with a map of the car and all that. And so it's not just the technology itself. It's all of the experimentation with any given form factor, with any given means of distribution that is going to start people thinking about what does this really mean. The very first films, for the first decade of films, people just pointed a camera at a stage and told stage plays, and then they realized, cinema eventually realized, no, different technology, different means of distribution, different way that things are received by an audience. You need a new language, a new vocabulary, a new ecosystem of distribution, a new way of talking about these things. So just looking at this physical object does not tell you what the trajectory is from Captain Kirk to using my Android to call an Uber. We're going to have to go through that, and that's the fun part. That's the exciting part. These are just the toys that we will play with to do it. All right, so when you think about, on some level, what this means, there'll be some point, maybe 2026, I don't know. There'll be some point where nobody's going to think twice about this. Of course there are virtual objects floating in the air down the street. You see them from your point of view, I see them from my point of view. Maybe there's virtual creatures. I look at them, you look at them, they look at each other, and we accept them as part of reality. And again, going back to that idea of the pre-literate culture looking at the magic of us having modern technology like writing. If anyone from a pre-literate culture watched any of you at a restaurant and you pull out the menu and you look at this piece of paper with scribbles on it, and it's got, you can't touch it, you can't taste it, you can't feel it, you can't smell it, you can't hear it, and yet we're looking at these scribbles and we're ordering food and it's total magic. I think that we don't think of it as magic, we think of it as reality, and we forget that that's virtual. I think that kids growing up with this, just as kids now, little kids just assume there was always pinch to zoom. Little kids will just assume there was always creatures floating in the air and virtual objects in front of us. They won't have known anything differently. So we've been doing some experiments for the last number of years at New York University. We've, in the last year, started collaborating with Maria Lanton, who's here today, at Emily Carr University. and with others as well. And we've been asking the questions. We can't live in that world of the future. Everybody's wearing the glasses. And some of you may recognize the vision I'm describing as being pretty much what Werner Vinge talked about 12 years ago in his novel Rainbow's End. We're not in that world yet, but we can play around with it. So I had an experience in September 2014. We'd been trying all these things for years, but then my friend Mike Woods, who at the time was at Frame Store in New York, handed me a Gear VR. And some of you might know that Gear VR anticipated some aspects of Google Daydream by about 2 years, in that what Samsung did was, and their partners, is they put the gyroscope into the headset because Android could not yet get high-quality 400 frame per second access to the little gyroscope that's already in your phone, even though it was in your phone, because the phones weren't made for it. And so you end up paying another $100, but what you get for that is that when you turn your head, the response, the rotation response is instantaneous and right on the mark, unlike, say, cardboard, where you're basically the 10 to 20 updates per second going through your web. So the nice thing about the Gear VR is when you look around, everything is rock solid. My very first thought when I saw the Gear VR, because we'd been trying all these things for years, was I have to buy a motion capture system. So I went out and we put markers on our Gear VRs and we bought a motion capture system, and everybody at NYU has been playing with this very happily for the last 2 years. This is like 16 OptiTracks that we have in our School of Engineering. We have another set of 12 OptiTracks in my lab, just for my little group of students, another 16 OptiTracks in Wynn Burleson's lab in the School of Nursing. And everybody is collaborating together. And of course, Maria Lanton already had Vicons because she was doing things like this. So the key is that it's untethered. And because it's untethered, unlike the Vive and its competitors, because it's untethered, people can have social experiences where they can freely walk around. You don't get as high quality experience as you do with the Vive, but you do get an experience of complete freedom of movement. And we can prototype that. And the reason we wanted to prototype this with phones rather than using the high-end backpack solutions like the Void and its competitors is that we wanted to prototype what this would be like, very lightweight, as much as possible the form factor that people would really have in their everyday lives. So people at NYU, this is our lab, started doing all these projects. We tried all different things. People are different sizes, you know, like the dollhouse version of the other people in the room. And I'm going to show you a few examples of some videos of some of the live experiences that we had. So this was something that we first showed at SIGGRAPH 2015. Then I'm going to show you a version of it that we showed last May at the FMX conference in Stuttgart. We just said, what happens if we're all avatars of ourselves? So I see you and you see me as though we're transported into the holodeck as cartoon versions of each other. We're in the correct place in the physical world that we are, but we can do magical things like draw in the air together. So as a social experience. Oops. I hear no sound. Why do I hear no sound? It's so weird. Okay. Well, so there's supposed to be sound, and for some reason there's no sound. It's very disturbing. But the sound is really just cool music, so think cool music in your head. And kind of a slightly German edgy music, because we did it in Germany. And so what you're seeing here is that people are basically drawing in the air, having a great time, and what you see and what I see, you and I each see cartoon versions of each other. And I think what I'm going to do for the next video is I'm probably going to open it up in another browser so we can get the audio. So I'm going to do that. So let's see if that works, actually. By the way, we were trying to think of a slogan to describe what we're doing. You know, we threw around a lot of slogans, like how do we define the, you know, this whole cutting edge of where things are going. So one we came up with that a lot of people liked, but there were issues, was we are creating the future, so you won't have to. But it turned out that that's really not the message you want to send people. So we're gonna give that one to the Trump campaign. So instead, we actually combined Gene Roddenberry with Jean-Paul Sartre, and now our slogan is, the holodeck is other people. And we think that that actually kind of is what we're getting at. It's really not about the technology. It's the other person who you're with is the most important part of any experience. So we did lots of other projects. I'm going to see if I can open this up in another browser. Let's see if I can do that, because then I might be able to get the audio. So I'm just going to find this on YouTube. And hopefully I'll find it, if it all works. So there are some things I said, you could applaud, because there are amazing people who worked on that. So that was a fairly large effort by a whole team of people who worked in a very interdisciplinary way. And I'll tell you a bit about how that came about. We did that, if you haven't guessed already, for the Day of the Dead, November 1st last year. All the computation that you're seeing in the graphics is actually happening entirely on these phones in Unity clients. We're using Wi-Fi multicasting to send the data to all the phones about where everybody is. And in this one, we decided to go minimal. Instead of strapping on anything to people's bodies, we just said, here, we put on a headset, and we're going to hand you 2 controllers, and we're going to make a very, very simple body so you can just go in and out, and it's very abstract, and people had no problem with it. So those ghost-like black figures are actually what the participants see of each other in the room. And we did things like set up real physical fans, and then you'd have a virtual fan that would blow air at you, but it would look like some fantastical thing. And what was really cool was to realize you can do a lot in Unity on phones if you design your graphics properly to create visually rich environments. The art direction was by our artist-in-residence, David Lobser, who's an absolute genius, and he led an amazing team of people showed up from everywhere in New York City, not just NYU, but also School of Visual Arts, professional animators. Everybody wanted to jump in on this project and work with it. And we had hundreds of people come through and have the experience. So let's see. We just kept working on other things because we sort of believe that the only way we're going to figure this stuff out is by creating experiences and having people constantly jump in and use them. So the thing that we just finished the other day was something, again, David put on this massive, massive experience at the Future Storytelling Festival in New York City. For 3 days, we had a throughput of like 1 person a minute, because we could have up to 30 people at the same time, all in the same room, all sort of hanging out together as birds in a flock. And I think if I do this, I'm not going to get audio, but you might not need the audio for this. I'm just going to talk through it. Well, maybe that's going to work, hopefully. there be audio? Yeah, so there's audio. So what you're seeing is a mix between what people are seeing in the experience, and then you'll see what's actually happening in the room. And people just were having such a good time. So the room itself is not huge, but there's this forced perspective, so people feel like they're in this vast space, and as they come up to each other, those people look like other birds, and you know, they're eating these fantastical like insects, and it was just like, people said it was a life-changing experience. So, and I believe them. So I think we're onto something here, because this is really starting to affect people from a very deep level, like this idea of you're being transported into another world, but with other people. We are going together to this social space where the rules are whatever we want them to be. And so then the questions include, what do we do with it? And to me, I feel as though, for me, the most exciting thing about this is, what is the most powerful superpower we start with? It's our ability to learn language, natural language, that every little child has. So I think that doesn't take that much imagination to imagine that if you look forward into the future, you could imagine a time within a generation when everybody's wearing, maybe first they're wearing the glasses, and then once everyone has the glasses, eventually, you know, it becomes normal and people start getting contact lenses. Eventually, maybe 20, 30 years from now, people start getting the implants, you know, because, oh, your child has the implants, so they're doing better at school. My child doesn't have the implants. In fact, people have already started writing. There's a comic book about like a world where every kid gets those, like, and so you always see stuff floating in the air. And that's what I'm talking about the age of computer graphics. Computer graphics is, within a generation, not going to be something I see here or something I see here. It's going to be here. Daniel and I are talking, and we're in the same room, and we're right in front of each other, and we could touch each other, and we will have computer graphics between us and anywhere we look, and that's going to mean that when I gesture in the air, that drawing could turn into something. So I've been very interested, and I've been working on this tool, I'm using it right now for this presentation, called Chalk Talk, where I'm trying to understand what is that future going to feel like when you just draw stuff. So some ground rules. I think a lot of computer-human interfaces, because they're not meant for conversational use, expect people more or less to be beginners. You have these menus, you have to kind of like, oh, what do I have to do? But there are things that assume people are experts. Musical instruments, pianos. If I go and join a jazz trio and I'm playing the piano or I'm playing the bass, no one's going to have any patience for, oh wait, I have to learn how to play the piano first before we start. Not only do I have to know how to play the piano before we have our conversation, but I also have to kind of know what a blues progression is or whatever it is we're doing. Same thing, you and I have a conversation. We do not take a dictionary out of our pocket and look up every word. We are all experts in our shared natural language, and that's why I can say the word elephant, and you start thinking about elephants, and it's powerful. So some of the ground rules is I want a drawing interface where you assume that eventually everyone is going to be an expert. And what would that be like in a world where everybody's an expert user, where, you know, somebody draws something and it's a shape we all recognize, and because we all recognize it, it has these properties like it comes to life because I drew it. So for example, you could even then draw like query objects that say, hey, all right, great, let's just find out about this. Oh, this is a pendulum. Of course, a pendulum has a roughly sinusoidal thing, and its frequency changes with length, et cetera. And you could actually imagine that turning into a kind of a physics lesson of some sort. But there are other things we could do. For example, if we're thinking in terms of people having conversations where things float in the air between us, and we're just talking about stuff, the line between making and talking starts getting blurred. Actually, let me show you a little, let me see, where is it? I have a little thing here, if I can find it. I think this might be it. This is Zhen Yi. She's one of the PhD students in our lab, has been doing some things where basically you can see this sort of tracked little robot, and she's making this gesture, and because she's making this gesture, the robot is coming toward her. And we have all these cool experiments where if you're in VR, you see an object that's across the room and you pull it towards you. And what's really happening is that a little physical robot rolled across the room and brought the water to you. But what you're seeing is, oh, it flew across the room and came to me. And I think this idea of VR is not just, and again, this was all in Vernor Vinge's book, VR is not just about I can see things that aren't there. It's also, like any technology, about I can not see things that are there. So, for example, the electrical outlets. We know there are wires. We don't have to see them. We go and we use the sink. We know there's plumbing. We don't have to see it. In the future, there'll be little robots running around doing stuff for us, bringing stuff. Oh, I want to have that thing over there. Bring it to me. And a robot will bring it to me, but I will never see the robot. The robot is just the plumbing. And with that in mind, we'll be able to decouple the power that we have with our bodies and our gestures from what we see, because we're interested in seeing what we are interested in seeing, which is our interactions with other people. You could do things like say, okay, so this, for example, is a gesture in Choctaw, in the Choctaw language, and that gesture means I'm going to work on a virtual potter's wheel. So now if I make a little shape, any shape that I make, it's sort of now built that surface of revolution. Those of you who do computer graphics won't be too surprised. That's just a graphical object. But I could do things like say, hey, I want to give that some material property. Maybe Daniel and I are having a conversation where I do that gesture, and now we think it's in the table in front of us. And as far as we're concerned, it's on the table in front of us. But we go out to lunch. The 3D printer starts printing. The robot that nobody sees puts it on the table. We come back from lunch. We pick it up. It was always there from the moment we made it, except it took time to develop to become the tangible representation of itself. And we're not even going to think, oh, the object doesn't exist yet. We're going to say, oh, it's not ready yet. It's cooking. And so I might do that. And then Daniel might say, well, I really like this, but because he and I share a language, he might say, I have these other ideas about that. And he might, use the language to say, I have this idea of like maybe some curve I'm thinking of that I want to apply to your object. And, and those of you who know graphics know this is just a spline tool, and you can start moving this around and changing it. But I think that the key here is that, oh, wow, my program froze. That's how you know it's a live demo. My program froze. So I'm gonna start it again, and hopefully it will work. My computer froze. My entire Mac computer just froze. Wow, that's crazy. Okay. Let's see. Did it really freeze? Yep, it did. Okay, so I have to stop Chrome, quit Chrome, start Chrome again, and hopefully I'll be able to get something done here. So hopefully this will work. We'll see. Who knows? In fact, this is all just running in the browser. So basically, Chrome froze because, I don't know, I probably had something weird in my JavaScript. So where was I? I was making an object. We were doing something with it. I don't know, whatever. And then Daniel came along in my little story, and he said, oh, no, I have a better idea about that. And so he connected his idea with this, and then, and then he can start in real time, start changing this and saying, no, this is really kind of what I think the shape should look like. And then I could say, Daniel, I really like the shape that you just drew, but I've been working on another project. Remember, it's a language. If it's a language, it's a grammar. You can combine things together. And I'm thinking, actually, what I really am interested in is, I'm not interested in that vase right now. What you reminded me of is that I'm animating a fish. And here's my fish, and what you've just done is you've created something really cool that could be like an animation path for my fish. So I'm going to connect your animation path to my fish, and my fish is going to start animating, and then we can start changing in real time how we animate the animation path. And no, this is not something that we're unfamiliar with. This is just grammar. We're making sentences with grammar. It's just that the things that we're using as our real-time components have some computational element to them. And I think that that's like a really important part of what's going on here. Now let me give you some other examples. Objects can also be information objects. Even the most ordinary objects are information objects. A light bulb is actually a transducer that transduces electricity, current into light. So, you go like this. But again, as I showed with the fan example, we can use them to create meaning, to explain things to each other. So, for example, I might be thinking, hey, I want to have something that responds to lights, and I want to explain it to you. So I might want to use a shared language. Like in my shared language, here's a camera, and what a camera really is it's something that looks for events and applies them to things. So then maybe this is, by the way, this is the only part of the talk, just so you know, that actually involves hand waving. I'm going to wave the hand in front of this, and it turns this thing on, turns this thing off. And so I was able to get across to you this very specific visual idea just by drawing some things. And we didn't have to over-prototype. We didn't, we just pulled out our visual tools and drew these things in the air. And I think that notion of we drew things in the air is a really important part of what's going on, maybe of what that future would be like. Maybe we're doing things like, when I teach my computer graphics class, there are concepts that are difficult to get across, like going back to the procedural texture stuff. So this is the very first thing that I ever made in WebGL. I made a little, this isn't really a 3D planet. It's totally fake. See, it's flat. So that's a fragment shader. And you open it up and you look at the fragment shader. And I can teach my students, and this could be like just conversationally between us, that they can go and make a change to the fragment shader, and anything they make is going to be immediately reflected. And then I can start hacking on the fragment shader, but it's part of a visual conversation that we are having. And I think that's really important. I'm going to give one more graphics example because I want to give you a sense of I'm already using this stuff in my teaching. And it turns out that in computer graphics, there are some concepts that are actually quite difficult to get across easily that I've traditionally stumbled on. You can draw them on the blackboard or the whiteboard, but then they just sit there and you can't make them move. Or you can run computer graphics programs, but then you can't tell the story of how things develop. So I'm finding that this combination of being able to draw things and then the things start explaining themselves is really useful for pedagogy. And I'm very interested in bringing that out into the space between us. So for example, one concept that I find very difficult traditionally to explain is coordinate systems. So we're all used to, like, we start with 2D because we see in 2D, but actually we're really representing a 3D world. And if you have an object, and we tend to represent simple objects as polygons in computer graphics, and we can drop that into a coordinate system, and then as we move the coordinate system, of course, the object is transformed with the coordinate system. But then I want to start explaining about transformation itself. And those of you who know computer graphics know that the key to understanding transformation is to really having a working knowledge of 4x4 matrices, because that's basically how you do linear transformations in 3D. And the different parts of the matrix do different things. If you just do things on the right column, you have a translation matrix. If you do things in the very middle, you have a rotation about x, because what you're doing is swirling y and z, and you can see you're leaving x alone. But then you can start instrumenting this. You can say, great, we have sliders. We can apply sliders to matrices, and now we have matrices in actual value. Let's make a more interesting range. And so now that's a matrix, and now that's because it's a visual language, and visual languages, by the way, go back to 1966. Bert Sutherland, Ivan's older brother, did a dissertation in 1966 where he described the first visual language. So all of us who are doing visual languages are kind of doing variations of what he realized half a century ago. But it's a noun, but it's also a verb. So I can take this and I can drop this in as an operation. And now what I'm doing is applying that matrix to all of the vertices. And I can show, oh, this is what it looks like to rotate about the x-axis. And people can see that because the x coordinates are not changing, sure enough, y and z are interacting with each other, but x stays the same. And if I did the same thing for y, you could see that, oh, this is spinning around the y-axis, and x and z don't change. And the nice thing about using visual languages for your explanations is you can bring, in fact, we did this before, you can bring in things like time that everybody understands. And time itself is not just a thing, but it's also an operator. So I can take time and I can drop that in, and instead of this being a value of angles, it becomes a rate controller. And I can say, oh, OK, we can spin faster, we can rotate about the z-axis, et cetera, et cetera. And one of the things I really like about all of this stuff is that you can play with all of these objects. This is a 3D object, exists in full three-dimensional space. And because all of this stuff can now, today, be done in HTML5, I wrote all my own little vertex shaders and fragment shaders and a little 3D modeler, which I can then share with my students. You can do things like say, oh, I'm just going to render it differently, and now it renders on the phone, and I can rotate it, and people can walk around in VR. And VR actually now is becoming much, much more accessible. So this thing that I drew, when what I thought of as 2 dimensions, is actually part of a 3-dimensional shared world that if we're all wearing whatever, whether it's 2016, 2026 version of the headset, we can all share this. So now, what's cool about this for me is that I I have these obsessions, these things that I'm really interested in, that I've always been really interested in. Like, I'm interested in animated characters, and I would love, as part of a conversation with someone, to just explain something to them and say, let me just draw an animated character, and that character kind of comes to life and, has properties, and maybe I can give it a color, I can tell it to dance or something. And this idea that you can interact with virtual objects as though they're real objects and they're going to be right in that space between us is so exciting to me. And it doesn't even have to be 3D objects. It can be very simple objects, like, I can draw a very abstract object. And as long as the shared language and the support we have understands these things, then this can be a creature that has its own personality, that responds to things. This little bird, for example, is really fascinated by my cursor. Where I look, he's going to watch the cursor. And he's watching the cursor specifically because he's actually quite ticklish. He loves that stuff. Oh, yeah. But then, of course, eventually they leave us. It's very sad. So this notion that anything I think of, if we build a shared vocabulary and a shared way of visual grammar. Now, I don't think that Chalk Talk in its current implementation is the right language. It's really just come out of some early experiments that we've been doing at NYU, teaching a graphic class, et cetera. I think it's far more exciting when it gets in the hands of kids and they can start building their own glyphs, and we started to add tools so that people can just draw and say, oh, that's a new glyph, it has this new meaning, et cetera. We've been starting to do this user-created glyph stuff that, and then that triggers that, et cetera. And building that sort of meta-visual language that users can use. And at that point, when millions of people are evolving it, they will start forming communities of shared vocabulary and shared grammar. And then, to me, it's kind of boring that I can teach matrices. What's exciting is when someone says, hey, here's what's happening with my relationship, or here's my thought about politics, or about this novel I read, or about like all the stuff of human discourse, and we can start bringing that to augment the language you already have in the space between us. Because my feeling is that the coming age of computer graphics is really going to be defined like this. It's going to be about a notion that things that we now think of as magic, like Harry Potter and his spells, or Harold drawing his purple crayon on the air, is stuff that people are just going to take for granted. It's going to be part of everyday life, just as I'm sure to Jane Austen, in 1812, it would have seemed magical that I take this box out of my pocket and talk to somebody halfway around the world, but there is no child in Toronto who thinks that this is magical. This is just reality. And I think once we get to a place where, Harry meets Harold and it's just normal, at that point it's going to kind of roll into the thing that people are good at. And the thing that people are good at is they see other human minds, like I said at the beginning, and they start talking to them. And they use whatever embodiment they can to start propping up that conversation, which is the real human program. So I would actually argue that many students here, the people who are just starting out in your research paths, when you think about the fact that you are about to enter a world which in the next decade will really be the age of computer graphics, we're not there yet, need to think about that your target customer in the future isn't someone like me, isn't someone like Daniel or Ali. Your target customer is somebody like this. And the more you can reach this person, the more you're going to have an enormous impact on the future. Thank you.
Do they all work? Hi, that was incredibly interesting. Thank you. Has there been any work done, two questions, and I think they're unrelated, but has there been any work done to integrate this with text analytics to improve reading comprehension?
We haven't done any, but I think that would be a great idea.
Oh.
So
okay.
You should do it.
Thanks. You'll accept me in your PhD program then.
Well, there you go. Okay. Just write that in your application, and I'll do everything I can.
Thanks. And then the other one is, have there been any functional MRIs or thoughts about it to maybe compare students who, I'm going to use the example of piano playing, to learn piano playing the traditional way and see the impact of their brain as it changes over the years versus learning, just virtually, like just using VR no physical keyboard?
Not as far as I know, but it's starting to sound like you're going to have a pretty amazing PhD dissertation.
Excellent, thanks.
Yeah, sure, yeah. Yeah.
Question. My name is Haijun, I work with Daniel, PhD student. There are some gestures you do in the interface, which is magic to me. I don't know how you achieve it, but it seems like some gestures has ambiguity in it.
Yeah, so for example, that's a very good question. For example, if I do this and I do this, so I drew left to right and bottom to up, and I got this coordinate system, but then it seemed like it did the same thing. It left to right and bottom to up, and I got this thing. And what was going on there is just that I have a language of hundreds and hundreds of words, some of which are extremely common that I use all the time, some of which are very specialized and I only use, say, for example, for my computer graphics, texture pyramids, whatever. And I wrote my own kind of least squares kind of thing. So if you look at this, that particular thing there comes from, there is a specific way of drawing it. Draw like this and draw like this. And actually, you had to draw in that order. And I decided, and I sort of I was influenced by things like kanji and hanzu and pictorial languages. I decided that it should matter what order you draw things in because people can learn that, and then it makes a vastly richer language. And in fact, that kind of extreme case, the fact that this was much wider than it was tall said, oh, that's going to be a slider. The other one is going to be a coordinate system. So, and I'm basically doing a kind of modified least squares fit. To fit everything.
So one thing I'm interested is so at the beginning you're drawing analog strokes, and then after you finish the stroke, it turns it into dynamic and animating stuff. So there is one you move from analog to this digital components. I'm wondering if you can keep building onto the analog components to so you draw the axis, you convert it to one dimension axis. Can you keep building on?
Yeah, so there's also, I can build new strokes too. I can start building new forms that I can then save into a library. This is all something that doesn't exist now. I have glyph builders and things like that. But, and then I could put little rotational things. So I have this sort of construction kit of making new things. But once they do exist, my policy, I've been playing with this since about February of 2014, and I tried lots and lots and lots of things. And one of the things is keep it very simple. Everything has to be really simple. And we were discussing this, Ali and Maria Lanton and I were discussing this over lunch today. When you're doing real time, when you're doing performance, which is what conversation is, for example, tools for performance, that includes pianos and banjos, that includes pencils for doing real-time sketching, basically tools for performing, game controllers, you cannot be thinking about them. They have to be feeling like they're extensions of your body, and you're just doing this thing. Puppeteers do not think of the puppet. They think of it as an extension of their body. That's me. I'm doing that. And so they start focusing on the audience and on the conversation. So anything you do for a real-time thing has got to be something where you're not thinking about it while you're doing it. And one of the many decisions I made was draw whatever you want, and when you're happy with your glyph, you click on it. And that turned out to be much, much better than any sort of progressive interpretation, because progressive interpretation requires me to pay attention to that thing, and that's a disaster. Yep. So that's some of the thought process that went into the design decisions.
Thank you.
Sure.
Hey, and so first off, thank you so much for the talk. My name's Sam, I'm a fourth-year medical student from Ottawa, so I'm actually not from the computer world, and by serendipity, I'm here. So what I'm wondering about is I do have an interest in healthcare innovation, and I was just wondering if you have ever experimented with the idea of incorporating visual reality with medicine, and if you ever see that as something that we can move on forward.
There's been a lot of it. A lot of people have done many things over the course of many years. Right now, I'm collaborating with Anat Lubetsky, who's in the physical therapy department at NYU, and she is using virtual reality, artificial environments, together with some pressure imaging mats that came out of our lab that actually we published at CHI a number of years ago. that are, the pressure imaging mats are telling you in a very finely calibrated way if somebody's starting to go out of balance. So it's like micro balance, so that you can't see visually. So it turns out that people go out of balance for all different reasons, and especially if people are over 65. If you're over 65, falling is the #1 non-heart disease or cancer cause of death, at least in the United States, and so you want people to not fall. And there are many things that keep us upright, lots of different subsystems, and it turns out that you can use virtual reality to give visual stimulus that says, oh, is it that I have no sensation in my feet? Is it cognitive? Is it vestibular? Is it proprioceptive? Like, what is it? And then you can start doing training. So things like that. There are a lot of opportunities to give people visual stimuli that the real world can't give them under controlled circumstances, and then start helping them because of that. And some of you are probably aware of phobias, pain management. There are all kinds of things you can do with VR.
Thanks.
Uh-oh.
So one of the things people started talking about a long time ago was the digital divide. Right? People who can't afford to be on the internet, connectivity.
Yeah.
What do you think the digital divide looks like when now we're in the same room, but some of us can afford to see one version of reality and others can't?
That's a really important question. I think that what ends up happening is that the basic function, people at first thought that cell phones were going to divide the world in a way that turned out to be different from what happened. What happened was we have our $600 phones, but people in certain small villages in India make sure that they have a phone. And now it turns out that they're super empowered because they can start having businesses without having a central bank, without having an internet. They can be doing things through 140-character messages, and then people start figuring out how to make those secure to do transactions. So I think I think people surprise you. You know, if once something starts having utility, they start finding a way. Like, for example, right now, one of the things we've been doing in our lab, because this is important to us, is like, yeah, $50,000 mocap equipment, whatever. You know, you university people, good luck, have fun. But we're also making low-cost versions of these things. We did a demo at the Weird Reality Conference. Maria was did that demo with me a few days ago, where we just use a phone. We use these. You know, these are the little Hamidos. I don't know if you know about these. They're awesome. Buy them on Amazon for 15 bucks. Or 16 Canadian. I don't know. And you know, and this is like HTML5. You know, it's just something that just runs on my browser. And if I do this, you know, and so now anyone who has a phone, I can be looking around, and I'm in a virtual world now, and I'm looking around it. And so what we've been starting to do is replace the $30,000, $50,000 OptiTrax with these cameras, plus you mount ping pong balls with LEDs. I think I have some video somewhere of my students showing that stuff off. So basically, you can get in the game. And I think the important thing, you know, for that classroom somewhere else in the world for this is that you do things in a way that anybody can get in the game, because people are enormously, once they get an edge, once they get part of it, they're enormously resourceful. And yes, when you're first doing the first research in a university, you need the high-end equipment because you need the general purpose, like you have no idea what's going to happen, so you need the general purpose instrument. You might need, you know, a touch interface with 1 millisecond latency, you know, like go completely crazy to ask the question, how much latency would you need, to use a random example. But he did that. It's like this guy did that. But then you have to also, to be responsible, ask the question, how do I make the version that hundreds of millions of people, several billion people could afford? We do need to be part of that solution. We're trying to be part of that solution by creating low-cost alternatives, and I think everybody should.
Okay, so it's 2 o'clock, so that's all the time we have. But please join me in thanking Ken.
Thank you.